Geothermal energy, a solution for sustainable development. Geothermal energy, a solution for sustainable development. Introduction. As the world continues to face the challenge of climate change, finding sustainable and renewable sources of energy has become imperative. One such source that holds great promise is geothermal energy. Why? Geothermal energy harnesses the natural heat from the Earth's core and provides a clean and reliable power source that can contribute to sustainable development. In this article, we will explore key benefits and potential of geothermal energy and how it can be a solution for sustainable development. Understanding geothermal energy. Geothermal energy is derived from the Earth's inner heat, which is a result of the radioactive decay of minerals and the original heat from its formation. This energy can be accessed through several methods. The most common one involves drilling wells into hot rocks and pumping water down to be heated by the geothermal resources. The heated water is then brought back to the surface as steam or hot water to drive turbines and generate electricity. Benefits of geothermal energy. 1. Renewable and sustainable. Geothermal energy is an entirely renewable source of power as it relies on the natural heat continuously produced by the Earth. Unlike fossil fuels, which are finite and have detrimental environmental impacts, geothermal energy can be harnessed without depleting resources or producing greenhouse gas emissions. 2. Low carbon footprint. Geothermal energy is classified as a low carbon energy source. It produces negligible amounts of greenhouse gases, such as carbon dioxide and methane, during operation. Utilizing geothermal energy can help reduce dependence on fossil fuels and lower carbon emissions, thereby mitigating climate change and its disastrous effects. 3. Reliable and stable. Geothermal energy is available 24/7, making it a dependable and consistent power source. Unlike solar and wind energy, which are intermittent and rely on weather conditions, geothermal plants can operate continuously, providing a stable supply of electricity. This reliability is crucial for meeting the energy demands of industries, residential areas, and critical infrastructure. 4. Local economic development. The utilization of geothermal energy can lead to economic growth and job creation in local communities. Building and operating geothermal power plants require skilled workers, engineers, and technicians, along with support services such as transportation and maintenance. As a result, geothermal projects contribute to the development of local economies, providing employment opportunities and attracting investment. 5. Diverse applications. Geothermal energy is not limited to electricity generation. It can be used for heating and cooling applications in residential, commercial, and industrial buildings. Geothermal heat pumps, for example, use the Earth's stable temperatures to provide efficient heating in winter and cooling in summer. This versatility makes geothermal energy a valuable resource for both power generation and direct-use applications. Challenges and potential for expansion. While geothermal energy offers numerous advantages, it faces certain challenges and barriers to wider adoption. 1. Resource limitations. Geothermal resources are location-specific and may not be available everywhere. The optimal locations for geothermal power plants are often in areas with active tectonic boundaries or regions with high heat flow from the Earth's interior. Expanding geothermal energy might require further exploration and investment to identify untapped resources. 2. High initial costs. Developing geothermal projects involves significant capital investment. Drilling deep wells and building power plants can be expensive, especially in areas where the resource is not easily accessible. However, once a geothermal plant is operational, the operating costs are relatively low, making it economically viable in the long run. 3. Environmental considerations. While geothermal energy has a low carbon footprint compared to fossil fuels, it still presents potential environmental risks. Drilling operations can affect local systems, and geothermal fluids may contain trace elements of harmful chemicals. Careful mitigation and monitoring measures are required to ensure responsible development and minimize environmental impacts. To overcome these challenges and unlock the full potential of geothermal energy, governments, investors, and the private sector must collaborate too. 1. This will help identify new resources, reduce costs, and enhance the overall performance of geothermal power plants. 2. Incentivize geothermal projects. Governments should provide financial incentives, such as tax credits and grants, to encourage the development and deployment of geothermal projects. These incentives can help overcome the initial high capital costs and promote the expansion of geothermal energy in regions with favorable resources. 3. Integrate geothermal energy in energy policies. Governments should include geothermal energy in their energy policies and set targets for its integration into national energy grids. This can drive more investments and create a favorable regulatory framework for the geothermal sector. 4. Raise awareness. Public awareness about the benefits and potential of geothermal energy is crucial. Educating the public about geothermal sustainability, reliability, and economic advantages will foster support and encourage the adoption of this renewable energy source. Geothermal energy offers a promising solution for sustainable development, given its numerous benefits and potential. As the world faces the urgent challenge of climate change, finding renewable and clean sources of energy is essential. Geothermal energy harnesses the heat from the Earth's core and provides a reliable power source that contributes to sustainable development. Geothermal energy is obtained from the Earth's inner heat, which is a result of the radioactive decay of minerals and the original heat from its formation. The most common method of accessing this energy involves drilling wells into hot rocks and pumping water down to be heated by the geothermal resources. The heated water is then brought back to the surface as steam or hot water to generate electricity. The benefits of geothermal energy are significant. Firstly, it is a renewable and sustainable source of power since it relies on the continuous natural heat produced by the Earth. Unlike finite fossil fuels, geothermal energy can be harnessed without depleting resources or emitting greenhouse gases. This makes it a more eco-friendly option for power generation. Secondly, geothermal energy has a low carbon footprint. During its operation, it produces minimal amounts of greenhouse gases such as carbon dioxide and methane. Utilizing geothermal energy can help reduce reliance on fossil fuels, which are major contributors to climate change. By switching to geothermal power, we can mitigate the negative effects of carbon emissions and work towards a cleaner and greener future. Moreover, geothermal energy is reliable and stable. Unlike solar and wind energy, which are dependent on weather conditions, geothermal plants can operate continuously. This makes geothermal energy a dependable source of electricity that can meet the energy demands of industries, residential areas, and critical infrastructure. Its reliability is especially crucial in areas with consistent power needs. The utilization of geothermal energy also has a positive impact on local economic development. Building and operating geothermal power plants require a skilled workforce, engineers, technicians, and support services. This leads to job creation and economic growth in the communities where geothermal projects are established. The attractiveness of geothermal energy for investment also simplifies the process of attracting financial resources to these areas. Furthermore, geothermal energy has diverse applications beyond electricity generation. It can be used for heating and cooling purposes in residential, commercial, and industrial buildings. Geothermal heat pumps, for instance, utilize the Earth's stable temperatures to provide efficient heating in winter and cooling in summer. This versatility expands the potential use of geothermal energy, making it a valuable resource for both power generation and direct applications.